Welcome to PM Ready, your guide to becoming PMP certified. This is the lesson on planning schedule, part 4. And finally, we come to the develop schedule process. This is the culminating process in schedule planning. It brings together all of the inputs from all of the previous processes and processes from other knowledge areas, such as resources, and brings them all together to create the main output of a schedule baseline, which is the approved version of the entire schedule model, which is all of the data about the schedule, including the project schedule, schedule data, and project calendars. This process of developing the schedule, as with other processes, in planning especially, is a very iterative process to develop and maintain the project schedule throughout the life cycle of the project. The schedule baseline can be used to generate several different schedule presentations or outputs. One is the milestone schedule. The milestone schedule is more than just the milestone list. The milestone list was a list of milestones that have been imposed upon the project for one reason or another. This is used as valuable input. However, the milestone schedule will be a more complete list of key milestones. You also have a summary schedule, which can provide a high-level picture of the main pieces of work and the main deliverables of the project. This will oftentimes mirror the milestone schedule, perhaps with a little bit more detail, but shows the starts and ends and durations of these different activities in the schedule. And then there's the detailed schedule. And there can be various formats for the detailed schedule, but the idea is that it includes more detail, such as all of the work packages and all of the activities that are in the project. Notice that this detailed schedule provides more information than your network schedule diagram, because not only does it show the activities and how they're linked together logically, but now it shows their durations. This schedule will also have taken into consideration the resources and resource availability, as well as any other internal and external factors that could influence the start and end dates and durations of these activities. In other words, this schedule, which is the output of developed schedule, is the final complete schedule that you can now baseline and begin work on. As you would expect, in order to generate a complete project schedule, you'll need to have as inputs all of the information and outputs that have been generated so far in doing your schedule planning, as well as your resource planning, as well as some other documents and sources of information. This list starts with the activity list and the activity attributes that go with that activity list, the project schedule network diagrams that you've created, the duration estimates that you've created and the basis of estimates, the milestone list, as well as any agreements that could affect the schedule, resource requirements, your project team assignments, and resource calendars being the resource information you need, your assumption log, risk register, and lessons learned register for information about assumptions, risks, and other lessons that can affect how you put together your schedule. And because we're doing schedule planning, we follow the rulebook defined in the schedule management plan. We also have the scope baseline, because there we have a lot of details about what is in the scope of the project, particularly in the WBS dictionary. And as always, some enterprise environmental factors and organizational process assets. Enterprise environmental factors include things such as government or industry standards. These could affect how you put together and finalize the project, including how you apply resources on the project and whether you can use overtime or different kinds of resources on your particular project. Communications channels is also listed here. You might ask yourself why. Why wouldn't communication channels apply equally to some of the previous project processes? They certainly do. However, they're emphasized here perhaps because the develop schedule process is the culminating process in schedule planning, and it's more needed than ever before to collaborate with the key stakeholders as you put together this final project schedule and baseline it. Organizational process assets that can affect the development of your schedule include your organization's policies on schedule model development and maintenance, which may also include specific scheduling methodologies that are required or recommended, as well as project calendars. Why project calendars? Project calendars are actually an output of this process, so why is it an organizational process asset? Because you have other projects that you need to coordinate with, and their project calendars can affect how you put together your project schedule. Moving on to the develop schedule processes, tools, and techniques, we start with schedule network analysis, which is actually a group of techniques that are used to develop your schedule. The first of these is the critical path method. The critical path method is used to determine the critical path through your project. It's a process that's a little bit involved, and so we have a separate lesson specifically for the critical path method. We also have resource optimization, which we'll get to, which includes both resource leveling and resource smoothing in order to adjust how your resources are allocated to the project. Another schedule network analysis technique is modeling, including what-if analysis and simulation. What-if analysis is when you ask yourself, well, what if this happened or what if that happened? For example, what if your tasks in a certain area take longer than you expected? What will that do to your schedule? And you can take that what-if analysis and apply it on a larger scale in some simulations. Other techniques you can use are to try and reduce the risks of multiple paths converging in your schedule and your network diagram. So your schedule network diagram has or will have some activities that have multiple arrows coming into them, converging into that activity, and that's a potential risk for schedule slippage. When you have something like that going on, you want to try and avoid slippage by looking at the previous projects, the preceding activities in the schedule, and see what you can do to avoid problems such as the student syndrome or Parkinson's law. Try and get those activities done early rather than letting them run until their scheduled due date. That way, if you can get them done early, you reduce the risk that any one of those will delay that task that all of these others converge into. You'll also want to take a look at risks on the critical path itself and see if you can come up with some risk responses specifically to reduce the risk of schedule slippage on the critical path. The critical path method is used to calculate the minimum project duration, the least amount of time that the project will take in order to complete. It also allows you to calculate the amount of schedule flexibility you have. And it does this by going through all of the activities in your schedule, starting with your schedule network diagram, and for each activity, calculating the earliest that it could start and finish. And you progress through from left to right, from start to finish, going one activity at a time. Then that's called the forward pass. Then you make a backward pass in which you review all of the activities in the reverse order, starting at the end of the project and moving your way back to the beginning. As you do this, you calculate the latest that each activity could start and finish. You can then determine the critical path through the project. as well as total and free float. The critical path is defined as that sequence of activities that represents the longest path through a project, and that determines the shortest possible duration. Float is kind of a measure of the amount of slack or leeway or buffer that you have in your project and along certain paths through your schedule. On the critical path, your total float is generally 0, unless there's some outside factor that is constraining the schedule. We'll get into the details of how you calculate the critical path and the total float in a separate lesson. As you develop the schedule, you'll want to use resource optimization. The two main types of resource optimization are resource leveling and resource smoothing. You use resource leveling when you are resource constrained, when you don't have enough resources to do the work as quickly as you would like. In resource leveling, you balance this demand for resources with the available supply. And this can cause your critical path to change. And as you're doing resource leveling, you use available float. And we'll get to that in a moment. In resource smoothing, you are time constrained, and that's your focus. The critical path does not change, and it does not delay your completion date of your project. And you delay activities only within the amount of float you have to work with. Here's a graph that shows an example of resource over-allocation. You should check to see if your software tool will let you visualize this type of resource over-allocation. In this case, we're looking at one or more resources that are over-allocated in these two columns, 1, the first one, and 5, the last one. So suppose these are weeks of time, and that in the first week and the 5th week, you have scheduled this resource for more time than is available. In this case, as you can see on the left, it goes from 0 to 10, 20, 30, 40, and 50. Suppose those are hours, and that you can't use these resources for more than 40 hours a week. So you have a problem that needs to be resolved. One way to resolve this is with resource leveling. This is the case when you're resource constrained, as we are in this example, and the end date can move. In this example, you can see we've moved the work that was assigned in that first week, and we've pushed it out and leveled it off so that we don't have any over-allocation in any of the weeks. Notice that we didn't just simply tack those in the middle. We had to actually extend this an extra week. In this case, it's because there were other factors and other things that this resource is working on that prevents us from using this resource fully in those other weeks. And so we had to add another week and put this extra work there in that 6th week. Now let's look at resource smoothing. You can see in this case we're not over-allocated, so we don't have a problem there. However, let's suppose you have a requirement that your resources not have their utilization change too much from week to week. Suppose you need to contract with a resource and they need a more stable level of work from week to week. And so what you can do here is we can reallocate things a little bit and get this pretty smooth so that it's 30 hours per week most weeks, 40 in that first week. We could even smooth this even more and have them completely equal. In this case, notice that we've kept ourselves within the bounds of the number of weeks that we started with, and that we're not extending the end date. That's the rule for resource smoothing. You've got to work with the amount of time that you have, and you can't push out the end date. If you end up pushing out the end date, then it's not resource smoothing anymore. Next, we come to data analysis. The first is what-if scenario analysis. This is simply asking yourself the question, what if this were to happen, or what if that were to happen, and using your software to plug in those changes and see how it affects the rest of your project schedule. Using modern software applications, this is relatively simple. For example, you could say, well, what if this particular task isn't completed in its estimated amount of time and it takes longer, maybe even twice as long? What will that do to the rest of our schedule? And you can look at all the different areas that are relatively high risk on your project schedule and play this what-if scenario game. You can do it one at a time like that, or you can use the power of computer applications to run some simulations. One type of simulation is known as Monte Carlo analysis. And that is basically taking what-if scenarios and doing them over and over again, thousands of times. For example, take your activity estimates. You have a range of estimates. You have your optimistic, your most likely, and your pessimistic. You could identify these ranges of durations, and you can run this simulation software to randomly simulate what happens if it takes more or less time, and those actual activity durations fall somewhere in that range. And you can use different probability distributions to make this more realistic. By running all of these simulations all at once, thousands of times, you can come up with an overall picture of how long the schedule is going to take. You can also identify different areas of risk and plug in different possibilities of different risks happening during the project and how that can affect the outcome. Here's an example output of a Monte Carlo analysis. Running this simulation over and over and over again, for each simulation, you measure how long the project took under those circumstances that were randomly generated. And you record that. And you record that thousands of times, and then you graph it here on a graph like this that looks like and is a histogram. By looking at this histogram, then you can draw some conclusions about the most likely duration of your project. In this case, you can see that there's some chance it could finish early. This middle area shows that there's an 80% chance that it'll finish somewhere in this range of time, and you've got a little bit of chance that it could take longer than that. Another technique you can use that we've mentioned before is schedule compression. You can take your normal project schedule and you can try and get things done faster by either fast-tracking or crashing. Fast-tracking is when you overlap activities that you would not have normally overlapped. This adds some risk to your project, but can help to shorten the schedule. Crashing involves adding more resources. By adding more resources, hopefully getting it done sooner, but at higher cost. For example, let's take a look at this schedule. Look at components 1 and 2. Component 1, you'll notice, will take a little bit longer to complete than component 2. What if we wanted to try and improve this situation? One thing we might be able to do is overlap the design and build activities of component 1. If it's feasible to go ahead and start building it before the design is completed. This may or may not be feasible, but if it is, you can buy some time and perhaps have less of a gap between the end dates between components 1 and 2. Another thing you could do is take a look at the testing of component 1. This is scheduled to take longer than the testing of component 2. Another thing you could do here is you could start integrating, which is the activity that comes after these, you could start integrating before the testing of component 1 is complete. There is some risk involved here in overlapping those tasks. The risk that it won't pass the test. But if it does pass the test, you've bought some time. Another tool, of course, is your project management information system, which will include all sorts of good scheduling tools that can help you with your planning. Also, Agile release planning. If you're doing Agile, the approach that you'll use is to come up with a release plan that includes the iterations and sprints in your release. Here is a simple example of an Agile release plan. Agile release planning provides a high-level summary timeline of the release schedule, typically 3 to 6 months. It focuses on the features. Looking here at the top, you've got releases 1, 2, and 3. It identifies which iterations of work are included in each release. And for each iteration, you can see the features or user stories that are included in that iteration, and you can see the tasks that are involved in each feature or user story. This allows for your project owner and team to see the big picture and decide how many iterations they need in order to have a valuable release. Let's take a look at a summary of the develop schedule process. The main output is the schedule baseline, which includes your project schedule, your schedule data, and your project calendars. Change requests won't come into play your first time around, but once this has been baselined, then you could have some change requests that have to be handled by other knowledge areas based on changes you made in the schedule. You'll also have project management plan and project document updates across a number of different documents, depending on the details of your schedule. Inputs include, of course, the project management plan, particularly the schedule management plan and the scope baseline. That includes a lot of detail that you need. Many project documents, many of which were generated by previous processes in schedule planning, such as your activity list and attributes, as well as some from other areas, such as resource management. You also have agreements as an input, particularly those with outside vendors, but also including those internal agreements that you may have with other departments, and some enterprise environmental factors and organizational process assets. Your main tools for developing your schedule are schedule network analysis, including the critical path method, resource optimization, what-if scenario analysis and simulations, inserting leads and lags as well as needed, schedule compression, and your project management information system. And if you're doing Agile, you'll also be using Agile release planning. Some of the trends and emerging practices in schedule management include adaptive planning, in which you start with a plan. You don't start with no plan, but you do expect and embrace change along the way. This is often implemented by using iterative scheduling with a backlog, such as with Agile approaches such as Scrum. Another example is on-demand scheduling, such as with a Kanban system, which uses a pull-based approach. Rather than scheduling ahead of time when things will be done, you pull the next thing that needs to be done as soon as you're done with the one you're on now. This is a concept that originated with lean manufacturing and also applies in the theory of constraints. These are a few concepts that we'll cover more in other lessons. Scope and schedule management are significantly affected by an Agile approach. Many of the tools and techniques and approaches are still applicable, but they're applied differently. In an Agile approach, you use shorter iterations, often time-boxed in fixed duration iterations, and each iteration ends in a review in which you can get feedback from your key stakeholders and adapt or course correct after each review. Agile also includes the concept of retrospectives, in which your project team reviews the latest iteration or sprint to assess how well it went and what impediments there may be or have been that could be used to improve the team's performance or velocity. And you can use a hybrid or combination of Agile and more traditional approaches. And that wraps up this lesson on schedule planning. For more information, you can refer to these pages of the PMBOK guide. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK guide.